Well, as we look at this problem here, we really have limitations on how much yellow we can have and how much green we can have. We have some yellow that is used in making each gallon of A because it requires 3 units of yellow. And also we have some yellow that's used in making color B, which is 1 unit. We also, with our restriction on the green, some of that green is used in the yellow, and, or not in the yellow, sorry, in the A, and some of that green is used in the B. So there's really 2 things we don't know. We don't know how many gallons of A, so I'm going to say A, sorry, just a second here. We don't have to use A and B. A lot of you prefer X and Y, so I'm going to say X is equal to the number of gallons of A, color A. And I'm going to say Y is the number of gallons of, okay, there we go. So we have this, and by the way, that's the magic of the video. You can make your messy handwriting look nice and neat. Now, if we're looking at number of gallons for X and number of gallons for Y, we obviously can't have a negative number of gallons. Our gallons for either color can only be 0 or something positive. So 2 of your inequalities you're going to have are X has to be greater than or equal to 0 and Y is greater than or equal to 0. Are you going to have inequalities like this in all your problems? No. On most, yes. Because most of these are real life situations that you're going to have to work out. And a lot of times negative amounts don't make sense unless you're, say, dealing with money or something along that line. Now, our restrictions are yellow of 32 units. Some of that's used in color A. Some of that's used in color B. Now, for each gallon of A, we use 4 units. For each gallon of B, we use 1 unit. So as we look here, we're going to have 4 units for each gallon of A, plus 1 unit for each gallon of B. Now this is our yellow. I know it's green text, but it's talking about our yellow up here. And how much we're using always has to be less than or equal to the total amount that we have, because we can never have more than that. So this is our yellow. Now, as we look at our green, okay, our green right here. And yes, I'm using the wrong colors. Sorry about it. Some of our green is used in the A. So we have 1 unit of A used, or 1 unit of green used for each gallon of A. But then we got to add in what we have here. And now we have 6 units for each gallon of B. Now this would tell us all the green that we have for the number of units. And that has to be less than or equal to what we have to work with, which is 54. Now, we have this written out nice and neat here. We are asked to find the maximum number of gallons you can mix. So that would be total gallons. And we know we have X being the gallons of A and Y being the gallons of B. So our total gallons, all we'd have to do is just go ahead and add those together. So the total number of gallons is X plus Y. So now, most people just struggle on setting this up. Once they have the inequalities, most people are able to go ahead and work this out. I'll just talk you through it. You graph these two right here, which are going to just put you in the first quadrant. Then you're going to graph these two inequalities, remembering only in the first quadrant. Find your corner points and put them into your number of gallons equation. Figure out which corner point gives you the maximum number of gallons.